Assalamualaikum warahmatullahi wabarakatuh and greetings. I am Kamil Khalil bin Haji Allah from Group 6, and today we are going to talk about Lab 2, which is flow over immersed body and boundary layer theory. In this experiment, the group will try to understand the flow over an immersed body and also the boundary layer theory. These aspects are tested in the airflow bench by observing the smoke flow over a symmetric airfoil body at different angles and measuring the velocity of air over the airfoil and flat plates. The results were measured, tabulated, and calculated to determine the outcome of the experiment. This allowed us to arrive at several conclusions for the experiment.
Assalamualaikum, my name is Nuri Antira binti Mak Yamin, MA18260 from Group C. Today I would like to present about the introduction of flow immersed body and boundary layer. Okay, boundary layer theory is a thin layer of a moving gas or liquid in contact with a surface such as an aircraft wing or the inside of a pipe in fluid mechanics. Net shearing force act on the fluid in the boundary layer. If the fluid is in contact with the surface, a continue of velocity occurs around the boundary layer from maximum to zero. The flow in such boundary layer is laminar, and the leading or upstream and turbulent at the trailing or downstream end. There are two types of boundary theory. It is laminar and turbulent. There are differences between laminar and turbulent boundary layer flow. Next, the turbulent boundary layer includes swirl or eddies, while the laminar boundary layer is rather smooth. For laminar flow, produce less skin friction drag than turbulent flow, but it is less stable. However, the low energy laminar flow breaks down more quickly than the turbulent sheet. Next, this part is about the background of flow immersed body. Firstly, external flow are generated when the object is completely surrounded by fluid. Secondly, the fluid force is also known as lift and drag. Third, to obtain the information on the fluid force generated by external flow, theoretical and experimental approach are used. Next, the general external flow characteristic in the case of an airplane moving through the air. The fluid far away from the body remains stationary as the body passes through the fluid at u. To make it easier, imagine a fluid moving past a stationary body at velocity u, also known as the upstream velocity. The speed is believed to be constant and uniform. Next, this part is about the categories of body. Okay, for the first figure, it is two-dimensional object of constant cross-sectional size and form. For second figure, bodies that are axis-symmetric, formed by rotating their cross-sectional shape about the axis of symmetry. Okay, for the last figure is three-dimensional body. A three-dimensional body with or without a symmetry line or plane. Okay, next, lift. Lift is a force acting perpendicular to the direction of relative motion between the fluid and the body. Low pressure is associated with high relative velocity, higher pressure, and a slower relative velocity. Okay, for drag is the resultant force in the direction of the upstream velocity. The rise is the resultant force that is natural to the upstream velocity and the fluid it is flowing through. Here, this is formula for lift and drag. This part is to calculate the characteristic area of the object for boundary layer. Okay, next, this is last part from me is problem statement is to analyze the flow patterns of symmetric aerofoil at different angle attack over the immersed body and body layer. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mama Amirul Ikmal bin Muhammad Zulmi. My ID number is MA181. So today I want to present the objective and the scope for the lab 2. So the first objective of this lab is to identify the fluid flow of pattern on the different angle of symmetry airfoil at the different angle of attack. The next is to determine the velocity of distribution for the flat plate, and the last one is to determine the boundary layer of thickness of a flat plate subjected to longitudinal flow for rough and the smooth surface. And for the scope, we will covering the theory which describe the boundary layer effects that was first presented by Ludwig Brandt in the early 1900s, and the general fluid equation had been known for many years. The behavior of fluid under various forces and at different atmospheric conditions, and to select the proper fluid for the various applications are understand. Then the theory of the coefficient is also used in this experiment to understand the effect of the shape of an object in the fluid flow.
Hello, my name is Stephen Wong Tak Ching, and I will present the chapter 2 theory. First is the object will experience a resistant force that hold its position from moving when the fluid passes through it. This force can be categorized to drag D, which act in the same flow direction, and lift L that act perpendicular to the direction of the flow of the force. When the fluid flow through the object that immersed in it is referred to as an external flow. The sharp boundaries can be increased inside the fluid medium. However, most external flow problems, including the flow fields and geometries, are too difficult to be solved analytically. In 1894, the H.F. Phillips built the first wind tunnel to measure the lift and drags. The stagnation pressure in the wake regions is higher compared to the zero angles of attack. When the dividing streamline and the stagnation point moving down, the air flow above the wing will be increased and the velocity below the aerofoil will be decreased. According to the Bernoulli theorem, the pressure will be increased when the velocity decreases. Therefore, the lift force will be generated when the pressure below the aerofoil is higher than the pressure above the aerofoil. The shape of body will affect the flow over the body and the velocity fields. There are three types of body are shown below. First is two-dimensional, is when the body is very long and the constant cross-section of the flow is normal to the body. Second is axis symmetric, is when the body possesses rotational symmetric about an axis in the flow direction. And the third one is the three-dimensional, is when the flow over the body cannot be modified as a two-dimensional or axis symmetric. The factors that can affect the boundary layer transition are pressure, skin frictions, heat transfer, body force, and free stream disturbance. When the fluid flow in the tubes, the boundary layer may be laminar or turbulence. It is depending on the Reynolds number. When the Reynolds number is lower, the boundary layer is laminar and the velocity is changed consistently. But when the Reynolds number is higher, the boundary layer is turbulent and the characteristic of the velocity is unsteady. Mostly the flow in the real situations, the boundary layer will develop or grow along the flat surface. That's all from me. Thank you.
Chapter 3, Methods and Procedure. In this experiment, we will be using the airflow bench, which consists of 15 different parts. In experiment 1, which is the airfoil model, the airfoil model was attached to the airflow bench and screwed down. The experiment was started with 0 degree angle of attack. The radial fan was allowed to move by turning on the switch. Initially, the speed controller of the radial fan was adjusted to 12. We recorded and tabulated the readings. Smoke was emitted by pressing the smoke controller to observe the flow of air on the airfoil. Flow of the airfoil was photographed. Speed of the radial fan increased to 19 by one step at a time. The step 3 to 8 of the experiment was repeated with angle attack of 20 degrees and 45 degrees. Next, in experiment 2, which is about the flow over the flat plate, the smooth surface flat plate was inserted into the airflow bench. The zero distance was taken as the first distance and the following distance was taken. The pitot tube was connected to the vernier calipers. And then the pitot tube is first touched to the surface of the flat plate as the first data. Next, the radial fan is then turned on and any data are recorded and tabulated. The distance of the plate is taken from 0 mm increased by 20 mm to 140 mm, while the pitot tube distance from the surface of the plate is taken from 4 mm increased by 4 mm to 32 mm. And lastly, the experiment is repeated from step 4 to step 6 for the rough surface.
Assalamualaikum and a very good day. I am Nur Azira binti Herman Tunchinho, MA 18232. Will continue the presentation about Chapter 4, Result Graph and Discussion of Laboratory 2. There are a total of 3 different experiments will be conducted. The first experiment is the flow pattern of symmetric airfoil at different angle of attack, in which this experiment is to study the flow over immersed body. The second and third experiment is to study about the boundary layer for flow over flat plate. The 2A experiment is for smooth surface plate, while experiment 2B is for rough surface plate. Thus, for all the experiments, there are a total of 5 formula will be used. The first one is to find the value of differential head, which the formula is initial head minus the observed head, h1. The second formula is to find the velocity by using formula of 2 times air gravity times the differential head, and then square root the answer, we'll get the velocity value. The third is lift force by using formula of force lift equal to coefficient of force lift times half times density of air times velocity to the power of 2 times area. From the slide provided, coefficient value is 0.84 and area is C times L equal to 0.0063 meters square. Fourth formula is drag force by using the drag force equation. It was same with the third formula except it has different coefficient for drag coefficient. And the last formula is the formula to find Reynolds number, which Reynolds number is equal to density given in slide times velocity times with L, plate distance, and then divide with mu given in slide 2. Thus, from the formula stated, data of calculation can be got as shown in slide for experiment 1 with different angle of attack of 0 degree, 30 degree and also 45 degree. Then from data, graph will be generated for graph lift force versus fan speed and also graph drag force versus fan speed. It shows that both graph has exponential growth, which lift force and drag force increase over fan speed for all angle attacks. And next is the sketching airfoil streamlines at angles of 0, 30 and also 45. Stagnation expression point is shown for each angle as shown on the slide. Next, experiment 2 that consists of 2A and 2B. For 2A, by using the formula I explained earlier, will then give data of calculation for differential head, velocity and Reynolds number. Then from the data, 4 graphs to be plotted, which are the first one is differential head versus boundary layer, next velocity versus boundary layer, Reynolds number versus boundary layer, and lastly velocity versus plate distance of smooth surface. All graph has logarithmic growth except velocity versus distance of plate for smooth surface that show slightly changes in decreasing. And last experiment is for rough surface. Same goes as previous one, just this time it used rough surface. After data is calculated, for graph will be plotted too. And all graph has logarithmic growth except velocity versus plate distance for rough surface graph that show as distance increase, velocity will be decreased too. So that is all from me for chapter 4. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. For the discussion for lab 2, By contrasting over the rough and the smooth surface, the effects of surface roughness on a turbulent layer are studied. The findings show that the rough surface has greater thickness than the smooth surface, and the form of surface roughness has an effect on the mean detect profile in the terminal boundary layers of the area, as well as the skin friction value. For the difference regarding result for the rough and smooth surface, the fluid flow of smooth and rough pipe of different diameter was compared in the pipe flow analysis and to determine the friction factors and Reynolds number. The pressure drop through the pipes was measured. To compare the smooth uniform flow at inlet and outlet, the energy equation is used. From the graph, we can compare that the Reynolds number versus boundary layer on rough surface is greater than Reynolds number versus boundary layer on smooth surface. Thank you.